today we're going to go over two different types of exponent rules. Before we do that, we need to go over something else. First thing is, we do not like negative exponents. The only time negative exponents are okay or acceptable is for when we're writing things in scientific notation. Okay, so scientific notation, it's okay to have a negative exponent. Exponent rules, not okay. So here we have an example, a to the negative n. We don't like negative exponents. So if I would imagine this as being a fraction, this would be written over 1. So all I have to do is move it to the denominator. That's really all we're doing. To get rid of a negative exponent, if it's in the top of a number, you move it to the bottom. If it's in the bottom, you move it to the top. So that means if it's in the numerator, you move it to the denominator, and vice versa. So our first example here is 2 to the negative third. I don't like negative exponents, so that will make that 1 over 2 to the third. And then we can figure out what 2 to the third is. It's 1 over 8. Because 2 to the third means it's 2 times 2 times 2, which is 8. The next problem, we have 6 to the negative second. So it would be 1 over 6 to the second, which is 1 over 36. The last two examples there, 4 to the negative second, you don't like negative exponents, so it becomes 1 over 4 to the second, or 1 over 4 squared, which is 1 over 16. Then the last one would be 1 over 9 squared, which is 1 over 81. We're writing these numbers as fractions. Okay, I know you guys can go and plug these into a calculator, but really it's understanding the process of how we get rid of negative exponents. Okay, the first type of rule that we're going over is called the product rule. So first, what does product mean? Think about, what do you do when you find the product of something? If you're thinking multiplying, you're correct. Okay? When we find the product of something, that means we have multiplied. Now, all we're going to do when we use the product rule is that for any numbers with the same base number, we add their exponents together. So for instance, this here we have is a to the m times a to the n. Well, if you look, these are the same base numbers of a. So what we would do is we would just add their exponents together. So m plus n. And that will tell us what our new simplified version is. What we're doing is we are simplifying these things down. So the first one, these have the same base number of 4. 4 to the third times 4 squared. So all I'm going to do is add my exponents together. So 3 plus 2 is 5. Then you could figure out what 4 to the fifth is if you'd like. I'm going to go down the line. I'm going to work in a column. Okay? I want you guys to figure out the process of this first, of knowing what to do with the product rule. Same base number of 3 for this one. So it's 3. Now I add my exponents. I combine them. 6 plus negative 2 would be 6 minus 2, which is 4. My exponent is positive. That's good. We don't want negative exponents. 5 to the third times 5 to the 0. So 3 plus 0 is 5 to the third. Now also remember, any number raised to the 0 power equals 1. So really we could have crossed that out right away. The next example, they both have the same base number of y. So I have y to the negative 3 plus 6 is positive 3. Okay. Now here we actually have coefficients, or numbers in front of our variables. So now we're going to multiply these. So 4 times 3 is 12. This x has a variable, has an exponent of 1. If it's not written there, then it's always understood to be 1. So we'd have x to 1 plus 4. So it would be 12x to the 5th. The last one, we multiply our numbers together. 3 times 3 is 9. R to the 6 plus 2 equals 9r to the 8th. Okay? And you can think about this as 3 to 3, they have the same base number and their exponents would be 1. So it'd be 3 squared. Then what, just figure out what 3 squared is. It's 9. 6 plus 2, r to the 8th. The second rule we're going to go over is called the quotient rule. So what are we doing to get a quotient? So with the product rule, we multiply to get a product. With quotient, we had to divide. Now, dividing with the quotient rule, when we're dividing, if they have the same base number, we subtract the top exponent minus the bottom exponent for if it has the same base number. Then look to see if you have positive exponents. If not, move them appropriately. So if you take the top exponent minus the bottom exponent, then if you get a negative exponent on top, you have to move that to the bottom. So let's try these 6 and then we'll do a few examples of each. So I'm going to work my way up and down. I'm going to work the columns first. So the first one, 5 to the 4th, all over 5 to the 3rd. Same base number of 5. This is a quotient rule because we're dividing. So we're going to take the top exponent minus the bottom. So 5, then 4 minus 3 equals 5 to the 1st. Do I need to write that to the 1st power? No, you don't. But is it hurting anything? No. Same thing, base number of 3. So then we take the top exponent minus the bottom. So I get 3 to the 4th. The last one in that column, take the bottom exponent, subtract it from the top. Okay, so 4 minus 5 is negative 1. Now think about it. Do you like that negative exponent? No. So where should it go? It's in the top. It's going to go on the bottom. We'll work our way back up to the top. Take the top exponent minus the bottom because they have the same base number. So 2 minus 4 equals x squared. To the negative second, I'm sorry. 2 minus 4 is negative 2. You do not like negative exponents, so you can move it. Another way to think about this, which would cut out that middle step, is one way you can do this is always move the smallest exponent. So here, my smallest exponent is on top. How do I get rid of this plus 2? So to get rid of a plus 2, you have to subtract 2. So we'd subtract 2 from that, which would cancel it out. Subtract 2 from the bottom. So on the top, you're left with 1. Bottom, you're left with x squared. Same exact answer, just two different ways of thinking about it. So here we can take the top exponent, which is negative 3, minus the bottom exponent. Here we have two negatives, so two negatives make a positive. So it would be m to the third. You can also think about that as where's your smallest exponent? Well, it's on the bottom. So how do you get rid of a negative 6? You would add 6 to both bottom and top. And that's how we'd get m to the third. And the last one on this page, we have numbers now in front of our variables, our coefficients here. So you need to simplify these if you can. So can we simplify 6 over 3? Yes. 3 goes into 3 once, 3 goes into 6 twice. So that 2 is going to stay on the top. You can move your smallest exponent, or always say take the top exponent minus the bottom. So you have 2y. Now we'll go through these on this next slide fairly quickly. So now, can I multiply these numbers together? Yes, this is a product rule. So 4 times 4 is 16. After I get done with one, I like to cross it out so it tells me I'm done with it. Product rule, I add my exponents. So here's a y, there's a y. So you could circle those if you'd like. Negative 1 plus 2 is 1. Done with that. X to the fourth. There's nothing to combine with it, so it stays x to the fourth. Your exponents are positive, so there's your final answer. Next one, 2 times 2 is 4. Do you have any other y's? No. So it stays y. Now the exponent for this x is a 1. So 1 minus 1 is 0. So remember, x to the 0 would equal 1. So I don't even need to write it. So there's our final answer. Because these cancel each other out. They simplify to 1. Two times 4 is 8. So I'm done with those. Combine my z's. That exponent would be a 1. So 1 plus 3 is z to the fourth. X to the negative first. There's no other x's to combine with it. But do we like that x to the negative first there on top? No, because it's negative. So now you have to move it to the bottom. And then y to the third. Nothing to combine with it, so it stays on top because it's positive. Now quotient rules. Can we simplify 3 over 4? No. So it stays 3 over 4. Any number raised to the 0 power is 1. So that simplifies the 1. I don't need to write it. Then x to the negative first. We don't like it because it's a negative exponent, so we'd move it to the bottom. There's our final answer. This one we simplify 4 over 3. We can't simplify it, so it stays 4 over 3. Next one. For my x's, 4 minus 2. So it'd be x squared. Y to the 0 simplifies to 1. So the y will stay on the bottom. Then the last one, I'll go through this real quick because I'm running out of time. Can't simplify 3 over 2, so it stays 3 over 2. The x's will stay on the top. Then subtract 1